Statistics students, this is the first half of Chapter 4 review. Chapter 4 is the chapter where we learned how to take various sampling methods, how to make good survey questions, how to design experiments, and such. In this lesson, we're going to talk about sampling methods and surveys. First off, this is the chapter where we made sure you know the difference between a population and a sample. Remember that the population is the entire group you'd like to study or draw a conclusion about. Any number that describes a population is called a parameter. Hopefully you remember that. Got to use the right words. The sample is a part of the population that you take data from. Any numerical value comes from a sample is called a statistic. So remember, population parameter, P, sample statistic, SS. The goal of this course is to use statistics to make conclusions about parameters. That's what we've been doing the entire second half. So remember that if you're making an inference about a population mean, the population mean is mu, and the sample mean is x bar. The standard deviation of a population is sigma, and the standard deviation of a sample is S subscript x. A population proportion is P, and a sample proportion is P hat. Don't confuse symbols. You will get points off for that. For example, remember when you're stating null and alternative hypotheses, you always use parameter symbols. So you say mu equals mu not equal to, or you say P equals or P is greater than. Never say that a null hypothesis is X bar equals. Never state that a null hypothesis is P hat equals. That's wrong. Now, when you choose subjects for a survey, there are different good sampling methods. In order for a sampling method to be good, that is, in order for a sampling method to be representative of the population of interest, you must use some form of randomness to draw your sample. So we learned 4 good sampling methods. The first one is called a simple random sample. We usually just call it an SRS, and you can even put that in your exam writing. That's where you leave the group whole and you randomly choose n subjects or units from the group. Then we learned that sometimes you need to take a stratified random sample because a simple random sample is not good enough. A stratified random sample is dividing the group into subgroups called strata, in which everyone has a common characteristic. Then randomly choose some from each group. That's the key element of a stratified random sample. Then you have the cluster random sample, which is also divide the group into subgroups in which everyone has a common characteristic, but then you're going to randomly choose a whole group or a couple of groups, and you're going to use everyone in that group or groups. And then you have a systematic random sample, which is the one where you randomly choose your first person, then you choose every nth person after that. So there will be multiple choice questions where you have to identify the sampling method. So let's take a look at examples of each. Oh, wait a minute, one more slide first. There are 2 bad sampling methods. A convenience sample is where you simply selected individuals because they were easy to reach. Convenience samples are no good because you didn't randomly choose the people. Then you have the voluntary response sample, which is allowing people to choose to be in the sample themselves by responding to some sort of invitation. Hey, call in. Hey, answer this email. Those are bad sampling methods. Examples. Consider Augusta Prep as the upper school at Augusta Prep as our population of interest. We want to conduct a survey to find out how upper school students feel. That's a population of roughly 140, about 35 of you per grade level. I want to survey 30 of those 140 students. How would you write if they said, describe to me how you would choose a simple random sample of 30 students? Well, remember, a simple random sample is keep the population whole. So I would do this. I would say something like, take an alphabetized list of all upper school students and number them. If you were using technology, you would say number them 1 to 140. We'll get into the other way of doing it in just a few minutes. Let's see, then randomly choose 30 unique numbers. Okay, so you're emphasizing there that you alphabetized the whole list of 140 students. You didn't separate them into groups. So, from A to Z, it's a mixture of 9th through 12th graders. Okay, a stratified random sample. Divide the upper school into grade level, 9 through 12. So you've got 4 different strata. So everybody in each strata has something in common, their grade level. Then number the 9th graders, 1 through whatever, and use technology to randomly select 7 or 8 and do the same for each grade level. Okay, so you're emphasizing that that a stratified random sample is dividing the population into groups and then randomly selecting some from each grade. Okay, now a cluster sample. Divide upper school into grade levels. Then randomly select a grade level. Survey everyone in that grade. Okay, systematic sample. Go back to alphabetize the list of all upper school students, number 1 through 140 or whatever, right? Randomly select a number between 1 and 10, then randomly select every 5th person after that person was selected or something like that. Hopefully that kind of sparks your memory there on the difference between the 4 good sampling methods. Now, convenience sample. Go to your first period, period A, go to your period A and your friends period A and survey. Well, that would be convenient and no good. Voluntary response. ask students to ask students if they want to scan a QR code for the survey. Okay, so hopefully that sparks a memory of those different sampling methods. Okay, moving forward. They could also ask you, instead of describing how you would use technology, they could ask you to use a table of random digits, and hopefully you'll remember this. I wish to choose an SRS of 5 people from a population of 50. Well, the first thing you have to do is describe how you're going to do numbering. So say something like, number the students 01 through 50. You could have also said 00 through 49, your choice. Okay. Number the students from 01 to 50. Start looking at 2-digit strings. Ignoring repeats and ignoring 2-digit numbers greater than 50. And stop when you have your 5. Okay, so the first 2-digit string I see here is 73. There is no person 73. There's another person 73, person 54, person 59, person 63. I'm ignoring. The first 2-digit string that makes sense is person number 13. Okay, the next 2-digit string that makes sense is 46. There is a person number 38. 73 doesn't exist. Person number 02. And 96 doesn't exist. 55, 83, 03. I have selected my 5. Okay, so hopefully you'll review how to use a random digits table. Now, let's just say, just in case, you might need to remember this. What if I said I had a population of 100, randomly choose 5? Well, if you number the people 001 through 100, this is horrible. There is no person 737. There is no person 354. There is no person 596. It's going to take you forever. So remember, if you have a population of 100, it's actually easier to number them 00 through 99. And so now, person number 73 got chosen. Ignore person number 54, person number 59, person number 63, and person number 78, and you have your 5 very quickly. This is also the chapter where we described the word bias. Remember that bias is intentionally or unintentionally favoring a certain outcome. Sometimes bias is obvious, intentional. Sometimes it's unintentional. There are different types of bias. Make sure you can put a name to the type of bias. Voluntary response bias occurs when subjects voluntarily choose to be in the sample, and people usually volunteer only if they have strong opinions. So you don't really get a good survey worth making an inference about. Undercoverage occurs when some groups of people are ignored or missed when the sample is being chosen. A good example of that is college students and homeless people being underrepresented in a survey. A survey sent by email ignores people without computers. Non-response bias occurs when some subjects chosen for the sample do not answer. So, in other words, ignoring the phone call, ignoring the knock at the door. Response bias occurs when subjects give incorrect answers. They lie, either because they've forgotten or they're just embarrassed about the answer to that question. So make sure you read up on those 4 types of bias and be able to identify that type of bias by name. Sample questions. A human resources director of a large company is interested in how often employees use their computers during breaks. She watches a selected group of employees at their desks during break times. This study could be described as an observational study. This question actually should go in the next lesson. Do you remember what a census is? Do you remember what an observational study, an experiment is? Another example. Which of the following does not contain a source of bias? So if you see a question like this, you've got to read every answer choice and see. A legislator wishes to know how his district feels about a particular issue. As a result, his office emails a long, detailed survey about the issue to a random sample of adults in his district. I think I can identify several sources of bias in answer choice A. Emails could result in non-response bias, and being long and detailed also could result in non-response. A polling organization uses a telephone directory to randomly select adults for a telephone survey to obtain opinions. Probably lots of non-response if you're using that phone. All 250 students at a review session are given numbered tickets. 5 numbers are randomly chosen, and the individuals with the winning ticket numbers each win a $10 gift card. Okay, I feel kind of good about C. A news show asks viewers to call a toll-free number. Oh, that's going to be voluntary response bias. So there's definite bias in that. A teacher asks high school students how often they drink. You're going to get response bias in that one for sure. Lies. Okay, so it looks like answer choice C was the only one that does not have a source of bias because randomness was given. A college counselor would like to select a simple random sample of all the 525 students in the college. She uses the numbers 001 to 525 to number the students in a college database, then uses a random number table to choose her sample of 30. What numbers correspond to the first 5? 063, so 63, 063. 856, that's ignore. 132, so I'm liking C and D. 063, 132, 751, 790, 36, 182. So it looks like answer choice D is panning out to be the right answer. 20 men and 20 women with migraine headaches were subjects in an experiment to determine the effectiveness of a new pain medication. 10 of the 20 men and 10 of the 20 women were chosen at random to receive the new drug. The remaining 10 men and 10 women received a placebo. The decrease in pain was measured for each subject. The design of this experiment is, well, we'll get into this one in the next lesson as well. Sorry it's in here. But this is a randomized block design by gender only. Drug is not a block. Drug is a treatment. Anyway, my apologies. We'll get into that one later. A student organization wants to assess the attitudes of students toward a proposed change in the hours the library is open. They randomly select 50 freshmen, 50 sophomores, 50 juniors, 50 seniors to survey. This situation is described as, they randomly selected some from each grade. That sounds stratified to me. So look for multiple choice questions like that. The head of the admissions office at a small college wants to understand why minority students who visit her school do not eventually enroll. The college holds a preview weekend for students who have been admitted. 2 months later, after the students have decided which college to attend, a survey is sent out to all minority students who attended the weekend visit but who did not choose to attend. About a third of them return the survey. 48% of those indicating they received a larger scholarship offer. Which of the following is true? Is the population of interest all college students? No. The population of interest is what? The head of admissions of a small college wants to understand why minority students. Oh, the population of interest is minority students who applied but didn't attend. So, I mean, they were just way off. The survey design suffered from non-response bias. About a third of them returned the survey. Absolutely. Because it comes from a sample, 48% is a parameter, not a statistic. No, that's backwards. Because it comes from a sample, 48% is a statistic, not a parameter. A parameter is a population value. 48% is a sample value. So it looks like 2 only is the correct answer. So hopefully this video kind of helps jog your memory of all the terminology from this first part of chapter 4.